Okay, so far in this unit, we've spent a lot of time doing a number of different things, but for the most part, they've all been centered around this concept of solving a system. But we spent a whole lot of time talking about solving a system of equations. And remember, our goal in those situations was trying to find a common solution that works in both equations. And we talked about the fact that you could find that common solution by graphing and looking to see where the two lines intersect at, and that would be the intersection point would be your solution. We talked about using substitution and using elimination as our other two methods to find out what that common solution would be, where that intersecting point would be. And then we spent some time talking about just inequalities and how to graph just a single inequality. Well, the whole purpose in doing that was to build up to this this lesson on solving systems of inequalities. It's similar to the idea of solving a system of equations, but remember, an inequality is not just a line, it's a region. And so when we solve a system of inequalities, instead of finding a common solution, we're finding a common region that would make a true statement, or that would work in both or all of the inequalities involved. So let's look at this first one. And in this video here, we're going to be looking at inequalities that are all in slope-intercept form. So with this first one here, we have y is less than 1/2 x plus 7. So I start out with my y-intercept being 7. And my slope is 1/2, meaning I'm going to rise up 1 over 2. And remember, even though it only takes 2 points to make a line, I want my line to be exact. So I'm going to come up with some other points here. So I'm going to continue my slope of rise over run, 1 over 2, to come up with some other points, or go backwards by going the opposite. Instead of going up 1 and to the right 2, I'm going to go down 1 and to the left 2. Doing so is going to give us, it's going to give us a more accurate line here. So remember, before I draw my line, I need to ask myself, do I use a solid or a dashed line? So for this one, it would be a dashed line. And now we're going to look to see if I shade above or below this line. Remember, when it's in slope-intercept form, and again, this trick only works if it's in slope-intercept form, we look to see what my inequality is. If it's less than, you shade below the line. If it's greater than, you shade above the line. So for this one, since it's less than, we would shade below the line, meaning that everything below this line would be a solution to this inequality. It would make a true statement if I plugged in that coordinate into my inequality here. But I don't just have just one inequality here. I have a system. I have two inequalities. The other one is just x is less than or equal to 2. Now remember, in a situation like this where we have just an x or just a y, they're giving us our intercept. In this case, they're giving us our x-intercept is 2. And it's less than or equal to 2, so it's going to be a vertical line. And it's going to be a solid line, not a dash. And it's less than or equal to 2, so I'm concerned about shading everything to the left of the line. Now watch what happens here. When we shade everything to the left of the line, we get this darker region. This red region would be our solution. Because remember, I said at the beginning, our goal in these cases are to figure out what region these two inequalities share. Because for that first one, everything less than that dashed line would have been everything in the yellow region, and everything to the left of the solid line would be our solution region for the second inequality. So the region that they have in common, let me leave it like this, I guess. So the region that they have in common would be this region that's marked in red. And we're going to call this region, this is called the feasible region. So that region there is the region where all of our solutions would come from. So if I pick a point that's in that red region, it would work in both inequalities. If I pick a point that's just in the yellow region, it would only work in the first inequality. If I picked a point that was in that purple region, it would only work in that, or only make a true statement in the second inequality. But in this red region, it works in both of them. So that's your feasible region. So let's look at the next one here. The next one starts out with a y-intercept of 3. and it has a slope of 1/6. I'm going to go up 1 over 6. 1, 2, 3, 4, 5, 6. If I try to go up 1 over 6, I'm going to run out of space, so I'm going to go down 1 into the left 6. And I'm going to use a solid line to connect these. The fact that it's greater than or equal to means that I'm going to shade above this line. So right now my feasible region is this area here. Now the next line is going to make this, it's going to divide this region into two other regions. So let's see how that works here. So again, my y-intercept for this one's -7. This one has a slope of 11/6, so I go up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 over 6 would be here. And I would use a dashed line to connect these. So again, this dashed line divided this yellow region into two different regions now. I want to figure out which region, either above or below that dashed line, that I would have as my feasible region. So to figure that out, I look at my inequality. My inequality there is greater than, so I would shade above the line. So everything above the line is part of my feasible region. So you want to make sure that when you're doing this, you want to make sure that you shade your feasible region to be darker than anything else. Or the other way you can do it is just simply shade in that region that would be your feasible region where our solutions would come from. Okay, so why don't you give a couple more a try. This time I want you to try these two on your own. So why don't you take a minute and work these out, and so pause the video and hit play when you're ready to check your answer. Okay, so let's see how you did here. Your graph should look like this. For this first one, y is less than -2x plus 3. You'd have a y-intercept of 3 and a slope of -2. So you go down 2 over 1, down 2 over 1, so you get this dashed line. And since it's less than, you'd shade everything below that line. The other one has a y-intercept of -6, a slope of -1/5. So remember, if you have a negative slope, that means you go down, and you always go to the right. So we go down 1 to the right 5, down 1 to the right 5. The only time that we go to the left is when we're going backwards, which in this case, if I'm going to go down 1 to the right 5, to go backwards, I go up 1 to the left 5, up 1 to the left 5. So there's your solid line, and you'd shade below that line, because it's less than. And so our common region is what they have in pink there. The other one, you have x is greater than or equal to -8 is your second inequality, so that's going to be a vertical line going through -8. And you'd shade everything to the right of that line. The other inequality, you have a y-intercept of 6 and a slope of 9/8. Now for that one, if you go up 9 over 8, it's going to end up being over here, but that's not a good place to go because you run out of space, so it's not going to be real accurate. So instead of going up 9 and to the right 8, we're going to go backwards. We're going to go down 9 and then to the left 8. And do that, you get this point right here. So now you can connect those with a dashed line, and that's your second line there, and we would shade everything below that line since it's less than. So the common region that they would share would be below the dashed line to the right of the solid line, which ends up being the region that they have shaded in pink. So hopefully you got those right, and hopefully you have an understanding now of how to graph a system of inequalities. It's not that much different from what we've been spending some time on the last couple of lessons. So hopefully you'll do fine on the assignment. So good luck with that.